The Pendulum Lab. Hi guys, before you get started on your lab, I just wanted to first of all thank you for working hard in my absence. I wanted to apologize for not being with you guys at these early critical weeks in our journey together for the term. As you probably know, my parents were in a car accident back east here in Vermont, and we're now in New Hampshire at Dartmouth Hitchcock Hospital, right next to Dartmouth University. They're taking great care of my mom. My dad is okay, except emotionally troubled. They ran into some black ice and went into oncoming traffic, and my mom's door got hit, and she suffered some pretty serious injuries, but she's fighting hard and doing well, and she's stable right now, and we're hoping she continues to do really well in the surgeries she's going to have, and it's going to be a long recovery process, but we're very, very hopeful. So I appreciate from all of you just doing your best, doing your work, and that's what's going to make me happiest is if I come back and you guys have learned and you're striving for continuous improvement. So let's get on with this Pendulum Lab. There's a few tips I wanted to give you before you dive in. All right, hope to see you guys soon. As you guys recall from your previous exploration of the pendulum, the weight, the number of washers, did not affect the period of the pendulum, how fast the pendulum oscillated, or the time it took it to go back and forth. But there was another independent variable we did not test, and that other independent variable we didn't test was the length that you guys proposed in your exploration activity that you did. So that's what this lab is going to do. We're going to be exploring the length of the pendulum, and we want to see how varying that length will potentially vary the time it takes for this pendulum to oscillate. And we're going to check how long it takes to oscillate 10 times. So here is the Pendulum Lab sheets that you all should have, and you could read through those, but the main thing is you're going to be measuring and setting the length of the pendulum in meters, and we're going to be setting it at these various settings of 0.2 meters, which is 20 centimeters on your meter stick, 0.4 meters, which is 40 centimeters, 0.6 and 0.8. So 20, 40, 60, and 80 centimeters, which we're going to put in meters, though, formally. So those are the different lengths. You're going to have 4 different lengths. Notice that we do have a length of 0, though, but since there wouldn't be any length, it wouldn't take any time to oscillate. So we already have one data point without actually taking data. So you're going to be varying the length, and that is our independent variable. And then you're going to be measuring how long it takes the pendulum to go back and forth 10 oscillations, so you count it going back and forth 10 times. 1, 2, and so forth. You start the stopwatch when it's at one side, and then you count 1, 2, and so forth. We'll talk about that in a minute. So anyway, you'll be timing 10 oscillations for these various lengths and recording them on the data table here. And that is our dependent variable that you're measuring, the time for 10 oscillations, and we measure that in seconds. Of course, before we start the experiment, I want you guys to make an educated guess on what's going to happen, and that's in the form of a hypothesis. So you will be writing a hypothesis using your pink reading graph sheet. If you turn to the back of your pink reading, or front, whatever, you turn to the side of the pink reading graph sheet where there's an SC and a claw in the little box, you'll see that there's a template for writing hypotheses that starts with the word as the, or starts with the words as the, and then independent variable and so forth. So you are going to be writing your hypotheses in this space, and I'll talk about that a little bit further too. This is where you'll be putting your data when you measure the time for 10 oscillations for each of these. This is where you're going to be drawing an illustration, a labeled illustration. So don't just draw the pendulum, but remember that we need to label it now. So label it and also show it in motion. Show a kind of a back and forth motion, and label where the length is, and label where the oscillations, the time for oscillations would be. Once you get your data in your data table, then you're going to use your skills that you've learned from graphing the last day here, and you're going to be putting the variables on the correct axes, titling it properly, zeros, and so forth. So you'll be graphing this data on this data table. And then after that, you will be moving to the back side of your sheet and answering all these questions. It might be a good idea to read those questions ahead of time. So that's what your lab sheet looks like and what you're going to be doing with that. So here we go, writing your hypothesis. Sort of the template that is shown on your pink reading graph sheet says, as the independent variable increases, the dependent variable will blank. Well, we don't write independent variable and dependent variable, we write what they actually are. So if you go back to your lab and sheet and you see what the independent variable is here, the length, then the dependent variable is the time for 10 oscillations. You can plug those in. And then I want you to look at the pink reading graph sheet and think what's going to happen. All right, so visualize it. If the length of the pendulum increases, the time for it to oscillate back and forth 10 times, will it be increasing or decreasing? And then if it pick one of those, increasing or decreasing, which makes sense, don't just pick it randomly, whatever makes sense. If it's getting longer, what's going to be happening if it's increasing or decreasing, and then how is it going to increase or decreasing? So this should be something like increases at a constant rate, or increases at an increasing rate, or increases at a decreasing rate. So you need to be very specific here, and those are the bold descriptions that are on your pink reading graph sheet to write the hypothesis right on your lab sheet where it's noted. Now that you have your hypothesis written, it's time to actually take data. So we already have one data point. That is, if the washer were just hanging or hooked on here, it wouldn't take any time to go back and forth. So your first thing you're going to be doing is you're going to be measuring down the meter stick. You're going to put your meter stick right underneath the extension arm, and right underneath here you'll unscrew the string compression screw, and you'll pull up on the string until the washer gets up, until right in the middle of the washer you can see 20 centimeters. 20 from, this is 0 up to 20. That therefore the length to the center of mass of the washers would be 20 centimeters, or 0.2 meters. And then you'll tighten the screw and you'll pull your washer back and you'll get ready to time. So that's how you measure the length. So after you're done with the 20, then obviously you're going to loosen the screw, let it go down to 40, so that the very middle of this you can see a 40 where that's 0. So 0 to 40 then, and so forth. So this should be getting longer. So it should be 20 centimeters, 40 centimeters, 60 centimeters, and so forth. It gets longer and longer. So once you get your length adjusted, again, you'll pull the washer back. Put your stopwatch right over here, right next to it. Don't let it clang when it comes back, but put it right next to it so it almost hits it each time. And you don't have to start it right when you release. In fact, it's better if you pull it back about 45 degrees here from the bottom, about midway, and let it go. Don't pull it way back here because it gets chaotic, but pull it back about this far, as you can see, and you'll let it go. And just keep letting it go until you can kind of time it up with your stopwatch. So when it comes back over here at a good time where you're feeling good, press start on your stopwatch right when it's here, and then it's going to go there and come back, and then you'll count 1, 2, 3, 4, and so forth until you get to 9. And when it comes back to 10 right there, with your stopwatch right near it, you'll press stop, and that'll be the time for 10 oscillations. And that's what you put as your dependent variable. And that's what you do for all the different lengths, and that's how you get all your data. And then from then on, it's going back to that sheet, graphing your data properly using your pink reading graph sheets and those steps you learned the other day, and use that graph to then interpret what really happened and think about what really happened to answer those questions. So good luck on your Pendulum Lab, and I'm looking forward to seeing you guys in the not too distant future here. Keep working hard and striving for continuous improvement. And Scratch's parting thought, and take good data.